All right. Okay? Cool. Answer time. So we have done magnesium. And we had... You can't see anything. Can you see it now?
Yep, we can see it now.
Better? All right, and the other thing we had was the hydrogen ions. Becoming hydrogen gas, like that. So that was our do now, right? Yep. So there's several different things I was asking you to do. First off was identifying which half equations which, and then using the terms oxidant and reductant. So before we even talk about oxidant and reductant, we need to identify which half equations which. In this first example here, we have magnesium, the element, becoming magnesium, the ion, which is 2+. And we see that it's losing 2 electrons in that process. We think about the acronym either oil rig, or if you're environmentalist, you can talk about lions. Leo the lion says grr. Either of those two will help, and what you're looking for is that terminology of loss of electrons. So loss of electrons is our oxidation. That's what those O's are telling me. So this half equation up here is the oxidation half. Now remember, you always have to have one of each because we can't create or destroy matter. We can't create or destroy these electrons. So in this case over here, I see that my hydrogen has added 2 electrons to it. So that's a gain of electrons, and gaining of electrons is reduction. So that's my reduction half. Are you okay with that so far? Bingo? All right, a hint for you guys to double check. You should always have electrons on each side of the equation. They should be the same number because they're going to cancel out. Oxidation, the electrons will always be on the product side because they're getting released. Reduction, the electrons are always going to be on the reactant side because they're getting taken in. Always going to be there. Okay? When we are talking about oxidant and reductant, that's when things get a little bit complicated because the vocabulary kind of switches around. When we are talking about oxidant and reductant, we are only ever thinking about our reactants. All right, so these two are the things you should be referring to. When you are talking about oxidant and reductant, you are thinking about what is that reactant doing to the other half of the equation. So since magnesium is providing the electrons to reduce the hydrogen ions, we call that one the reductant.
What?
So this is my reductant. I know, I didn't write this, all right? I wasn't the person that decided this vocabulary. Because we're talking about what it's doing to the other half of the equation. So magnesium is the reductant because it is reducing the hydrogen. Okay? Hydrogen, on the other hand, it's accepting those electrons. It's taking them away from the magnesium. So that makes the hydrogen the oxidant.
Oh, wow.
The hydrogen ion is oxidizing the magnesium. That's why we call it the oxidant. It's the strange way with the vocabulary. It just swaps around. All right? It wasn't my call. It makes sense, though, when you kind of think about it in that way of what it's doing to the other half. Sure? Are we okay with that? All right. What questions do you have following that? Do you guys feel like you need some practice with this?
Yes.
I thought so. All right, so let's go back to the lesson plan for today. All right, cool. So in these equations that I've shown you guys, I have made the electrons very visible, and that has made your life really easy because then you can tell which one's losing electrons and which one are gaining electrons. However, not all equations are going to do that. And in fact, these equations might be combined together, and you won't see the electrons. And so then we need to figure out what's going on. So for example, I could have the following equation. 2FeO, so that's iron oxide, plus carbon makes iron, Fe, and carbon dioxide. So that's my equation there. Let me just focus it back in again. Come on, you can do it. You can do it. There we go. All right, so the trouble that I have with this equation that I'm looking at is that I can't see the electrons, and thus making it really hard for me to identify the oxidation and reduction half reactions. So what we use to help us figure that out is something known as oxidation number. You might also hear it being referred to as oxidation state. I'm going to write state in parentheses because sometimes you hear it referred to as oxidation state, but more often you're going to hear it being referred to as oxidation number. What that is a number that is getting assigned to our atoms, and that's telling us the degree of oxidation or reduction. Say atoms or elements to indicate the degree of oxidation or reduction. And I'll show you guys how we apply it so you guys can actually see it working. With oxidation numbers, we're going to make observations for the reactants and the products, and we're going to see if those oxidation numbers have changed. If those oxidation numbers, and I'm going to abbreviate them as ON because I'm lazy, if those oxidation numbers have increased in value, what that has told me is that we have lost electrons. And with losing electrons, that is my oxidation. If that oxidation number decreases, that tells me that we have gained electrons, and that is my reduction reaction. So you're still using the same terminology with loss and gain of electrons, but now we can add an extra layer with the oxidation numbers to help us figure out what's happening. Are we okay with that so far? Shall I apply it? All right. So looking at the equation above, we have 3 different elements, and we're going to go through each one of those elements and assign them their oxidation numbers to figure out how they have changed. Now, in order to do that, we are using this yellow piece of paper, which is called our oxidation number rules. Unfortunately, we do not give this to you on the assessment, so you do need to memorize these rules. The good news is that they're pretty logical, and they're, I think, more or less pretty easy to memorize. So, I want us to start with the oxygen. Now we have oxygen in our iron oxide, and we have oxygen in our carbon dioxide. And what we're looking for is to see if that number for that oxidation number has changed. So, when I'm looking at my rules, one of the nice things is that oxygen is listed under those rules. And it says oxygen in compounds has an oxidation number of -2. And they've given me a whole list of examples. The rules? You can have the yellow piece of paper. There's a yellow piece of paper that I just passed out. That is for you. Okay. Better? All right, so do you see how I'm looking at number 3? Oxygen has the oxidation number of -2 in compounds. They've given me a list of examples to help me kind of see what those are. There is an exception to that rule, and that's if oxygen is in hydrogen peroxide, so H2O2. If it's an H2O2, the oxidation number is -1. Are we good with that so far? So when I look at this equation, oxygen here Is that in a compound?
Yes.
Yep, it is. Iron oxide. Is that compound hydrogen peroxide? No, because I said iron oxide. So this oxidation number is -2. All right, I have oxygen and carbon dioxide. Is that also a compound? Yes. So my oxidation number is -2. Has my oxidation number changed? No. So what that tells me is that since the oxidation number hasn't changed, oxygen is not involved in this redox reaction. We good? Keep going? Okay. Let's now look at the iron. So, iron, we have to remember, is iron oxide. Do you think that iron oxide, if we're trying to figure out the charge of that ion, what do you think that charge would be? So I have iron and I have oxide. If you guys remember, oxide is a -2 charge. What should iron then be? +2. How do you know that, Neil? You don't know? Because it's an ionic compound. And so with the ionic compounds, those two numbers need to add up to 0. So we know that this iron here is actually iron 2 oxide. Are we good so far? All right. Let's now look at my list of rules to see, does iron fall on this list? So I see things about elements. I see things about oxygen and hydrogen. I see things about polyatomic ions. I see things about molecules. But do I see anything specifically about iron? No. But there is actually rules to iron that we can apply. The one that we are applying is elements as monoatomic ions have the oxidation number equal to the charge of the ion. So this has a charge of +2. So this will be +2. And actually, I have the plus slide on the wrong side on that one. All right, are we okay with that so far? All right, something I want to point out to you guys. You see how this one I have the positive side before the 2, and this one I have it after the 2. When the plus or minus is after the number, that is referring to charge. When it's before the number, it's referring to oxidation number. So just watch out for that. All right, keep going. Okay. Next, I have iron, and this iron's in its elemental form. I can see there's no charge on top, so it's not an ion. Again, I look at my list of rules, and I'm seeing which rule applies to it. Oh, the first one. An element has the oxidation number of 0. And that iron is in its element form. So that is my 0. Now, do you see here how the oxidation number has gone from +2 to 0? Is that increased or decreased? It is decreased. So what that tells me is that the iron here is getting reduced. So this here, if I'm looking at that example, iron is being reduced. And on top of that, the iron oxide is the reductant. So we have Fe going from +2 to 0. So that is a decrease in oxidation number by 2. It is gained, how many electrons? 2. Therefore, reduction. And our iron oxide is the oxidant. So do you see how that helps us figure out information that we would have otherwise missed? Happy so far? Yes? All right, shall I do the last one? You ready? Ready? Last one? Nope. Still ready? That's okay. We'll take our time. You guys can probably figure out carbon from that list. So like I said, we unfortunately are not going to give this to you. You're going to need to memorize this. The best way to memorize it is just to practice using those rules. So that's why the homework that I've assigned tonight is really helpful. All right, keep going?
Yep.
Okay.
Can I just take a picture?
Yeah, I'm going to scan it as well, so it's going to get online. All right, carbon, based off of these rules, what should the oxidation number be? Because I can see it's an element.
Oh man, so you're taking that?
No, you can keep those. Those are for you to keep. But you can't use them on the assessment. Okay. All right. So carbon's in its elemental form. What oxidation number should I have for it? 0, just like we did with iron. All right. Now, carbon and carbon dioxide is going to be a little bit tricky because when I look at that list, is there anything on there that says carbon and giving me a rule for carbon? No. So what we're going to do is something called oxidation math. I'm just going to move it down. So here's what I like to call oxidation math. And we do this whenever something doesn't follow the rules. So when I think about carbon dioxide, I have carbon and I have oxygen, right? Now there's several different rules that I can apply with this. The first being that the oxidation numbers in a molecule, the sum is 0. So this overall molecule has the oxidation number of 0. The other rule I can apply is my oxygen one again. Oxygen compounds, -2. So what we do is we set up a simple equation. If I have carbon and I have 2 oxygens, now I like to annotate oxygen as OX so that way it doesn't look like a 20. And that's what makes carbon dioxide. Let's substitute in the numbers that we talked about. So carbon acts as my X, just some basic algebra stuff. I have 2 oxygens. Each oxygen is a -2, so I'm timesing that by 2. And carbon dioxide as a compound is set to 0. So I have X plus -2 equals 0. X equals +4. Just algebra. Shall I repeat myself, Charlie? Do you want me to repeat myself?
No.
All right. Everybody else okay? All right, so the oxidation number of my carbon over here is +4. Are we okay? All right, using that information, carbon is going from 0 to +4. So my oxidation number has increased by 4. Have I gained or lost electrons then? If I'm going up, I've gained or lost? Electrons are negative, so I've lost them. So we've lost 4 electrons. And therefore, do I have an oxidation or reduction reaction? Oxidation. So do you see how you should always have 1 of each? And that makes carbon, as my reactant, the reductant. And that's how I can figure it out. All right? The best thing to do to learn these rules is to practice the equations, because there's no point in memorizing it. You want to apply them. Most of them we have covered. Some things to keep in mind is we haven't done the hydrogen one, but hydrogen in compounds has a +1. Unless it's in a metal hydride, then it's -1. We've done the sum of the molecule equals 0. If you have a polyatomic ion, such as sulfate, you then set it equal to the charge of the ion. So instead of setting it equal to 0, you set it equal to -2, because that's the charge of that ion. The other thing to keep in mind is that you're going to have to use multiple rules. So if I have oxygen in a compound, it's -2. But if I have oxygen in the element form, it's then 0. Best thing to do is to practice them. All right? Cool. Tomorrow for the workshops, I'm available session 1 and session 2. I haven't scheduled anything specifically for those 2 sessions, so just pop in whenever works. Come in for most of you guys need to come in because you need to finish up your titration. If you can't make it to the Friday session, it's your responsibility then to figure out another time to do it. Because we can't do any more class time.
Do we have 5 minutes?
We have bio last period, so if you want to leave your stuff here, you're more than welcome to. And I think that's it. There's no STEM scheduled for tomorrow. So you guys can just focus on getting your assessments done.
Is there any talk tomorrow?
Huh?
There's no coming
For the STEM talk? No. Next week, I have 2 forensic scientists talking. Next week, I have 2 forensic scientists talking. So, forensic scientists. The surgeon's already come. Or sorry, the ER person's already come in. I recorded it and I put it onto the STEM Google Classroom page if you want to watch the conversation. That was last week. She was an ER doctor and pediatrician. Yeah. So you can watch the video.
Where?